Well, so far we talked about how to calculate integrals, but sometimes we have to deal with complicated integrals, and we need to have some techniques that help us to solve them. For example, we're going to talk about how to use a method that we call integration by parts that help us to calculate complicated integrals. So today's objective is talking about integration by parts. Very well. So we are on chapter 7.1. Integration by parts. Let me write down the formula for you, then go over some examples. Integration by parts. So suppose you have integral of function f of x times the derivative of another function g prime of x dx. We can rewrite this integral as f times g minus the integral g times the derivative of f d of x. Or if we have the integral of u in general dv. So g prime of x dx can be just simplified and written in shorter format of dv, the derivative of another function. This is equal to u times v minus integral v d. This method is called integration by parts. This method is very useful. You're going to see that we have tons of different integrals that using previous methods, using direct integration or substitution, those are not very helpful in finding the integrals. For example, one example for you here. If somebody asks you to calculate integral x times sine x dx, what would be your approach? How do you start calculating this integral? Well, okay. In this case, you might say, well, I learned something new today. I know f g prime of x dx is nothing but f times g minus, then instead of taking the integral of f g prime, I can calculate the integral of g f prime. Now your job is to identify what is f, what is your g prime. Just keep that in mind that when you try to use this method, integration by parts, our goal is to simplify the original integral. So just take a look at the first equation here. In this equality, here we have f of x times g of x minus the integral of gx times f prime of x. Okay. You might say, if I take this one as my f in the integral, f prime is going to be 1. So I only left with the antiderivative of sine, which I already know how to handle. So let us try this. I'm going to show you if we use a wrong f, a wrong g, what happens if we select a correct f, a correct g, what would be the result? So let me just use these two. So suppose this is your x, sine x, dx, and you say that, well, this guy is going to be my f. If this is your f of x, then sine x dx is your g prime of x. This is your, let me use a different color. This is g prime of x dx. Well, let's follow the formula. The formula says, hey, you can rewrite this guy as f times g. F is f, x. But what is g? What is the integral of sine? It is negative cosine minus the integral of g, which is negative cosine x, times f prime of x dx, which is the derivative of f1 times dx. So this guy is equal to minus x cosine x plus integral of cosine x dx, which is equal to minus x cosine x plus sine x plus c. So when you select correct f and g prime, you can easily take the integral. Again, note that your job is to make sure you have a nicer version of the original integral, something that you already know how to calculate. However, if you say your f of x is sine and your x is g prime dx, let's see what happens. You get a more complicated integral this way. So this is, let's put the happy face here, sad face here. The integral of x sine x dx. So in this case, suppose this is your f. Suppose you decided to select sine to be your f and x dx to be your g prime of x dx. So if you follow the formula, you have f of x times g of x. It means that it is now f of x, which is sine of x, times g of x. G of x is the antiderivative of x, which is a half x squared. Half x squared minus the integral of g f prime of x. G is a half x squared times f prime of x, the derivative of sine is cosine. Now, as you can see, I increased the exponent of x inside the integral, which makes it more complicated. By selecting a wrong f and g prime, you get a more complicated, more complex integral. So by practice, you check to see which one of these make the integral much more simpler, much more easier. And then after a while, you see, well, as long as I have something like x, linear expression, quadratic expression, something to power n, that is f. Why? because we try to reduce the exponent from 1 to 0, from 2 to 1, and so on. Okay, give us more example. Well, suppose you have this guy here. It says calculate the integral of ln of x dx. Okay. ln of x dx. Remember, this guy is the integral of ln. Recall that. What we learned before is the integral of dx over x is ln of absolute value of x plus c. Do not confuse this integral with the integral of dx over x, which is ln of absolute value of x. This guy says, hey, what is the integral of ln of x? Well, you might say, hey, here I might see f of x, but what is g prime of x? Since g prime of x is not visible, you might say this is 1 times d of x. So you can actually write it as 1 times dx. So let f be ln of x, and 1 times dx is your g prime of x. Our formula says this is equal to f of x, so I'm going to copy down ln of x times g of x. G of x is the antiderivative of 1. The integral of 1 dx is just x plus c. So this is just x minus the integral of x, f prime, the derivative of ln, is 1 over x. 1 over x dx. Okay. Cancel out x and x. This is equal to ln of x times x minus the integral of dx, which is ln of x times x minus x plus c. Another example for you. Suppose the question says, well, evaluate the integral of t squared e to the t dt. Very well. Remember that when we have linear, quadratic, cubic, or other terms, expressions, it's good to start by taking those as your f. Why is that? Because in the integral, you can reduce the exponent and it makes it easier to calculate the integral. So let us try to take this guy as your f. So f of t now, and e to the t dt is g prime. dt. Well, okay, the formula says this is now just copy down whatever your f is, t squared, and g of t, which is the antiderivative of e to the t. We already know that this guy is equal to e to the t. minus the integral of the antiderivative of g times f prime. F prime, the derivative of t squared is 2t dt. Okay. So we started from t squared. Now it's reduced into t to the first power. You should be asking, can I apply integration by parts for this integral? The answer is yes. So we apply the method of integration by parts again. So this guy is equal to t squared et minus 2. I'm going to write down 2 in front of the integral. It's just a scalar, it's just a number. E to the t times t dt. Now again, take this guy as your f. Try to reduce the term that you have, f of t, and e to the t dt is your g prime of t dt, and apply the integration by parts one more time. So this is equal to t squared e to the t minus 2 parentheses f g. So I have t times the antiderivative of e to the t, which is e to the t minus the integral of g times f prime. So g is just e to the t, and f prime, the derivative of t, is just 1. Well, you're happy here. Why is that? Because we know that how to calculate the integral of e to the t is just e to the t. So this integral is equal to t squared e to the t minus 2t e to the t plus 2 e to the t plus constant of integration. Don't forget to distribute the negative 2 into parentheses. That's how we get plus sign. Very well. Suppose we have this guy here. Well, we have the integral. Now you have a definite integral 0 to 1. Inverse tangent of x dx. Okay. Inverse tangent. Well, I already know that the integral of dx, this is a recall for you, dx over 1 plus x squared is inverse tangent of x plus c. But this guy is asking me to find the integral of inverse tangent. Okay, well, I need to decide what is f, what is g prime. If I take f to be inverse tangent, then I already know that the derivative of inverse tangent is 1 over 1 plus x squared. Remember that. If you take the derivative of both sides, this is equal to inverse tangent derivative. So I already have this information. Let us go along, see how much we can go further, if we can get something nicer, easier to work with. Okay. Suppose this guy is your f of x, and your g prime is invisible, so it is 1 times dx. 1 times dx be your g prime. G prime of x dx. Okay. Well, following the formula says this guy is equal to f of x, which is inverse tangent of x, times g of x. The antiderivative of 1 is just x, minus the integral of g of x, which is x, times the derivative of inverse tangent, which is 1 over 1 plus x squared dx. Well, okay, look at this integral. You can easily use u sub to calculate this integral. And this is definite integral, so don't forget to plug in 0 and 1. Eventually, we're going to do the calculation. So far we have inverse tangent of x times x from 0 to 1 minus the integral x dx divided by 1 plus x squared. For this guy, we're going to use u sub. So u is equal to your denominator, 1 plus x squared, and du is 2x dx. So it means that x dx is du divided by 2. This is equal to inverse tangent of x times x, 0 to 1, minus integral a half du over u. But we already know that the integral of du over u is ln of absolute value of u plus c. So far I have inverse tangent of x times x, 0 to 1, minus a half ln of absolute value of 1 plus x squared, and my x starts from 0 and goes to 1. So if I plug in 1, I get inverse tangent of 1, which is pi over 4, minus, if I plug in 0, it's going to be 0, so I'm not really worried about 0, minus a half. Here I have ln of 2, minus ln of 1, this guy is 0. So the final answer is pi over 4 minus a half ln of 2. Well, in 7.2, we're dealing with trig functions and their exponents. We're interested in learning how to deal with those integrals. For example, what if we have the integral of cosine to the third? What should we do then?